So thank you for welcoming me to the stage, and it's again a pleasure to be here at Geekle. It's not my first time, not my second time. I have been there for a while, like 2 years now. So I've been moderating and speaking, so I'm quite used to it. And you're doing a great job at moderation, so it's nice.
Thank you for that. So yeah, let's start. I'm personally very happy to listen to your speak because I'm a total fan of Quarkus. So I need to see what's new.
And we can have some stuff to talk
Okay, I'll
about
leave you.
after then. Thank you.
Go
Okay, so today's presentation is going to be called Hands-on DDD and EDA with Quarkus and Kafka. So it's a lot of buzzwords in the same sentence. So DDD stands for domain-driven design, not development. EDA is event-driven architecture, and Quarkus is a Java framework like Spring to make whatever you want, CLI, web development, native application. And Kafka is a message broker for things. Okay, and Kafka is a message broker. It's a lot of topics, and I don't have much time, so uh, I will be I will do my best to make it quick and just pinpoint you into great uh, conversation. And if you want and have any feedback after, and I'll be glad to talk with you and share about these topics. So, okay, just a little about me. My name is Gaëtan Bloch. I'm French. I have 11 years of the field of software development, and currently I'm a software architect and technical lead for Key Consulting, which is a great French consulting company, and I have a pleasure working there. So there is my social account if you want to reach me. So let's go. What about the agenda? So first of all, I will do an introduction to domain-driven design. Uh, we will take this talk about a use case, a small use case to apply DDD and EDA to it. Otherwise, it's a bit dark to present this concept. We will first talk about DDD strategy design, what it is, then tactical design. Then we will talk about behavior-driven development, BDD, which is a very misconcept and really necessary for me when you're doing DDD. Uh, After that, we will talk about implementation and how in my project I implemented this microservices-driven architecture using hexagonal architecture for each microservices. We'll talk about Quarkus, of course. What is the anatomy of one microservice? We will recap what is event-driven architecture and talk about the different patterns that I'm using to consolidate my architecture to make it work. So the Outbox pattern, the Saga pattern, and the Securus. Securus stands for Command Query Responsibility Segregation. So, introduction to DDD. First of all, I cannot speak about DDD without mentioning these two books, especially the first one, famously named The Blue Book, which was written in 2004 by Eric Evans, who is the father of domain-driven design. I cannot believe it. It's 20 years ago, and we're still not fully impacted by this methodology. And now it only starts to really emerge in every project that you can see. And the second book is the Red Book, followed by the Blue Book by Von Vernon, who talked more in details and added some concepts about domain-driven design. So what is DDD? So it's a methodology that models software based on real-world business concept and processes. It emphasizes the importance of understanding and modeling the domain of the problem you're trying to solve. So basically, you have to know the model. What's important? It's the domain. Domain can be business. It's really the core of this methodology and its design. And it promotes collaboration between domain experts and developers. So we're involving all the stakeholders. Everybody has to speak the same language. Everybody has to speak the same word, even if it's French, even if it's German, Spanish, you have to speak the same language. Either it's on a conversation with a product owner or with a client, or when it's in your code, even in deep inside your code, you have to use the same ubiquitous language, because that's how you can understand fully the business. And that's what DDD is about. So the methodology provides a set of principle and complex patterns for designing complex software design. This is the strategic design. We can talk about domain events, bounded context, and context maps. After that, it helps to identify and define the core concept and the relationship within the domain. So this is where tactical design enters. You can have to define entities, value objects, and aggregates. I will dig deeper in that after. What does it lead to, DTD? It leads to, in my opinion, at least, higher quality software that meets business needs more accurately, as it's designed around the problem domain rather than the technology itself. So you have to abstract yourself whether it's a UI, it's a web app, or is it going to persist in an SQL DB or no SQL, or is it going to be in a graph DB? The technology doesn't come into the mind of people before long after you talk about the domain and the business. This is the most important. And last of us, it facilitates adaptability to business changes as the software model evolves together with their understanding of the domain. And we call this evolutionary design. Okay, so I will take a use case. I will take a meal ordering system. I will make it very simple. This doesn't have, and I want to say, this doesn't have to be a microservice architecture. This doesn't have to be event-driven architecture. This can be a modular monolith, a distributed monolith. I'm just talking about microservices because for the purpose of talking about it, not because the application needs it. I want to state this. So this application is about customers ordering meal products. There is a payment system. Restaurant prepare the products, accept the order or not, and customer can track the order. That's it. So let's start with what is DDD strategic design. DDD strategic design is about, as I said before, ubiquitous language. You have to share language between domain experts and developers. This is very, very important. It's all about business. Ensures clear and consistent communication, reducing misunderstandings and improving the accuracy of the software design. Second, we have bounded contexts. Bounded contexts for me are, there's many words for this. You can call them domain, subdomain, and it can end up being a microservice. It can be ends up being a module of your monolith. But for me, it's a unit of business where everybody speaks the same language. So it defines explicit boundaries within which a specific model and ubiquitous language is applied. They allow for a clear separation of concern and help manage complexity in large software systems. Context mapping. Context mapping is the mapping between different bounded contexts. So I will show you after a bit. Basically, you identify different contexts like order, payment, restaurant, customer, and then you have to map them between each other, like which one is using the other, which one is conforming to the other. So it's a technique used to define the relationship and the interactions between those bounded contexts. After that, we have the domain events. Domain events are very important because they drive everything after. For me, domain events is the start, as we will see in the event storming session, because domain events define your use case, define your scenarios, define the actions of the business that will occur in your application later on. So it's a state. It's those events enable loose coupling and asynchronous communication between different parts of the system, promoting scalability and flexibility. After this, there is like the strategic aggregates. I will talk again about aggregates later, but they are clusters of objects related in a single unit. They encapsulate business rules and protect the consistency of the domain model. This is one of the hardest thing to define and to identify and to implement. So I will go deeper into this after. And there's the core domain. In DDD, you have different types of domain, and the core domain is the one which gives you the which makes your application or your company worth it. Basically, why this is the core domain. Why is it for, and what you have to do for this core domain, and what is it going to do for your application. And this core domain needs to be identified in the beginning. Your application needs to to be direct about this core domain. If you're doing meal ordering, it's about ordering. So during this process of tactical strategy design, Alberto Brondolini invented, quotes, the process of event storming, which is a collaborative workshop technique that helps to uncover and model the domain by capturing events and their relationships. So I advise you to go to his website. He's very thorough about it. And it's a technique that involves all the stakeholders from different domains coming together for a workshop style session. So basically, everybody is coming either virtually or in person, and they have post-its, they have labels, and they put it on a whiteboard, and everybody is putting his part of it. Developers, stakeholders, domain experts, principally domain experts because they know what they want and they know what the business is about. So this aims to uncover the essential events and business processes within the domain by encouraging open discussions and knowledge sharing. To be honest, it's better in person than virtually because you can have like a 2 miles long dashboard, and if it's a big business, it's quite interesting to participate in that. So you use sticky notes and cards to capture domain events. You start with the domain events, and then you map those events to relationship, commands, and users. So I will, for my application, I will do just a small example of this. Uh, let's say my application is very small. It's just a meal order application. So let's say we're 3 people and we just like brainstormed and then put some sticky notes like order created, order paid, payment completed, order rejected, customer created, payment canceled, order canceled, payment failed, order approved. Basically, that's how it starts. Everybody puts the sticky notes about business actions, domain events. So you collect those domain events. Then you refine them. You put them into consistent and cohesive units. So you can identify already orders, payments, order rejected, order approved, maybe can be done by someone else, like the restaurant, and the customer created can be somewhere else. And we end up with something like this. So the yellow sticky notes are the actor, the blue sticky notes are the commands, and then we still have the domain events there. And you end up with something like this in a really simple way. The user order leads to an order created. The user pay leads to a payment completed or failed. The user wants to track the order. The restaurant might reject the order or approve the order. And a user has to register itself before ordering, of course. So this is really, really a quick, not recap, but quick introduction to event storming. So now let's talk about tactical design. Tactical design is more about like how you're going to implement after. You're going to use entities. Entities are objects defined primarily by their identity and life cycle rather than by their attributes. Value object is a very powerful pattern because in your code, you don't define a string name or a string first name or a string, for example, zip code, something. You give names to objects. You give names to types. An address is an address. It's not a string, street, string, postal code, string, country. It's a value object which is immutable at a t time. So as I said, we're going to come back on aggregates. Aggregates are clusters of domain and objects, entities and value objects that can be treated as a single unit, having a root entity, which is the entity, who ensures the consistency of the other entities as a whole. And it's known as the aggregate root. Domain services is an operation that does not conceptually belong to any object, and it can be implemented in a domain service. These services contain domain-specific only operations. Repositories are a mechanism for storing, retrieving, and querying aggregates, and factors are a way to encapsulate and create complex domain objects. I will pass on this. So basically, about tactical design, I come back to the event storming I was doing before, and it can seem really rushy, but we identified like 4 contexts that can become microservices: one order, one payment bounding context, one restaurant bounding context, and one custom bounding context. And with talking with the stakeholders and the business, we identified order root, which is the order aggregate root. We identified value object like address, money. We identified other entities order item, product, restaurant, customer, which reside in one bounded context, which will after become one microservice, in my example at least, not every time. So you can see how we can get out those aggregates, which is a really, really difficult thing to do. A small part of behavior-driven development, which is for me really essential and important. And I want to go through some misconception about this. It's scenario focused, so it's business focused. It's use real life scenario to define software behavior, provide a concrete example that express what should happen in a specific situation. It's a collaborative approach, so it encourages collaboration between technical and non-technical stakeholders. You can put it in your user story, you can put it in your specifications, you can put it in your test plan. And it leads to understanding the behavior, and it will lead to the implementation after. Like DDD, it emphasis on ubiquitous language, and there's a big misconception about BDD, and it's often misconstrued as a testing technique. Like when you use Cucumber, okay, it's about acceptance test. It's about like end-to-end test. No, it's not. It's a design. It's a methodology, not a testing technique. It helps you understand the behavior and design your use case after. It guides you into implementation of the software, ensuring it aligns with the intended design and business needs. It helps validate that the right software is being built. And BDD is an awesome complement to DDD, a scenario derived from event storming and DDD strategic tactical design that we expressed before, and can be implemented using BDD. About BDD, you can use anything you want. You can use Cucumber, you can use SpecFlow, you can use any tool you want, or just plain unit test. It's just a guide, it's just a methodology, it's not about technology. So let's now talk about how implementing this. I'm a big fan of hexagonal architecture, or the call onion architecture. Uncle Bull calls it clean architecture. So what is it about? It's about ports and adapters. Hexagonal architecture, also known as ports and adapter, organizes the code into several layers of functionality, which the core business logic is in the center. So it aligns with DDD because you put the logic and the domain in the middle. That is what it is about. And that's what we want in DDD, and that's why we choose to use hexagonal architecture. It's domain-centric, as I said. it isolates the domain, the business rule from the framework, from the UI, from all kind of noise that you can have other than business rule, which is the real thing that matters for customers. External systems communicate through well-defined ports and adapters, which is basically an inversion of control, dependency injection kind of thing. The domain doesn't know about who is implementing him or who is going to use him. He just takes care about himself. And this architecture is about interchangeability. This architecture allows the ease of change from one external system from another. If you want to go from Quarkus to Spring, you can. If you want to go from Java to .NET, you can. It focuses on use cases, and use cases, it's, for me, exactly the implementation of BDD. For BDD, you have one scenario, you have one use case. And hexagonal architectures directly support DDD, as I said in the beginning. So this is a really great one article from 2018, and you can go to the website, and I took it from here. So it can be cumbersome, but basically you have on the left the user interface, which I call presentation layer. We are outer. In the outer layer, and the infrastructure on the on the right side, which is all the search engine or database. On the left, you have UI, CLI, REST controller, and in the middle, you just focus on the application and the domain. And they are really tightly coupled. They are not tightly coupled. Domain is really isolated, and it go outwards. It go inwards, instead of going outwards. So the dependencies goes inwards. Domain doesn't depend on application. Application doesn't depend on infrastructure or presentation. It's just implementation, port, and adapters. Let's get down to some technical points. I don't even know how much time I have left. Not much. So what is Quarkus? Quarkus 3 is an awesome framework. I was a big fan of Spring before, and I'm still. And but Quarkus is just awesome. I'm very biased, so I can only do so well. So it's container first. It's minimal footprint Java application, optimal for running containers. Quarkus doesn't have to be compiled natively to work better than Spring. It just optimized even for JVM-based application. You don't have to go native if you go Quarkus. This is a misconception. It's cloud native. It embraces the 12-factor architecture in an environment like Kubernetes. It's actually Kubernetes native. It's made to be deployed in the cloud. It unifies imperative and reactive programming. You can do at the same time, which sometimes doesn't make sense, reactive and imperative programming with non-blocking queues, with non-blocking operation and blocking operations. It's standard-based, so if you are a Java expert and you're not tied to any framework yet, it's the standards of Java. It's JAX-RS, Hibernate, JPA, Native, Vertex, MicroProfile. It's all about Java, not about adding a layer of abstraction. It's the same as Spring Boot. It's just a utility, and it's helping you a lot. It's microservice first, so it brings the lightning fast after time to code turnaround to Java apps. For example, if you compare native, it's great for serverless application in Java. And it's developer joy. I can testify about this because it's developer-centric. It recompiles at runtime to make you rock around and play with it, and it's just a joy building application with it. And now I cannot make an application in Spring anymore. So for my application, what is the anatomy of one microservice? So basically, I have one microservice in the middle, which is the main microservice, let's say, which is order. It uses Quarkus. I'm not talking about domain right now. I'm talking about all the technology surrounding the microservice. So you have all the standards encapsulated with Quarkus. You have REST-easy, small wire for active messaging, microprofile, Eclipse specifications for OpenAPI, and many other things. You have GDBC, GPA, and Jakarta persistent. GPA is now Jakarta, and Hibernate for the ORM, OpenTelemetry for distributed tracing, Micrometer for the metrics if you want to put your metrics in Prometheus, and GBoss logging if you want to put your logs in Fluentd in a Kubernetes environment or in any cloud. Basically, I just want to focus on one microservice in particular, just to give you actually, because this is one of the things I struggled the most when I started this hexagonal domain-driven mix design. So basically, there's the order at the top. On the right, you can see there's the application. First of all, there is the domain. There's the entity. So we identified the body context order, which has entity, customer, order item, product, restaurant. There's one error. There are events which are exactly the domain event we identified before: order canceled, order created, order paid. There is one domain service, and there's all VO, which are the value objects, which are meaningful for the application, which is address, money, identity, quantity, stuff like this that have meaning, that encapsulate primitive types. On the right side, we have the application, which is the upper layer of the domain, which has common query when you do Securus, which has the DTOs, which are the object that you transfer for the from the, for example, a REST endpoint or something. There's the error, the mappers, messages. Now we can talk about messages, and we will talk further about it. And ports, mainly what I mentioned about hexagonal architecture, which are two kind of ports: the input port, which are the use cases. And that's where BDD comes in. You have one use case, you have one BDD scenario, and you are implementing it in this use case. Those are interface. They are implemented in the order command handler, but they are the interface exposed to the REST endpoint that I will show later. And the output port are interface that are implemented by the infrastructure, like the GPA repository, the ORM, anything you want. So I'm going to the infrastructure. So you have ports, and then you have adapter. Adapter implements ports. That's what we said. So secondary ports implements the customer repository. Order address are the entity in JPA term, not the entity in terms of DDD. And you have mapper. And on the presentation, I have only one adapter primary, which is an order resource, which is a REST endpoint. So event-driven architecture. Event-driven architecture, what is it? It's a design paradigm where software components communicate through events. I think I need to go faster because I still have stuff to do. It's synchronous communication. It's about decoupling. It's about well, it doesn't make sense if you're in a modular monolith to use event-driven architecture. It's when your microservices are isolated and do their work on their own. It's about scalability and resilience. It's about consistency, which allows you to implement patterns like Outbox, like Saga, like event sourcing. It's about aligning your implementation with the DDD focus on domain events, because those domain events becomes domain events in the sense of events in your event-driven architecture, actually, which makes total sense to me. So now let's talk about the Outbox pattern. The first picture is from Debezium. So in the Outbox pattern, the idea is to not have two-phase commits. You want to be able to publish even to other microservices within the same transaction than you want to actually persist your entity inside your inside your microservice database, because each microservice has its own database, and you cannot fire an event and persist to your database in the same transaction, because uh, it can fail. One and the other can fail. If you send the event but the persistence failed, then you're in trouble. If your persistence occurs but your event failed to be sent, then it's also troubling. So basically, the Outbox pattern makes you persist your event inside persistence unit, a database, and your entities inside the same transaction. So this is all that is about. There's two different techniques about this. There's like the pooling technique, where you have this a scheduler who is checking on the Outbox table, and there is the technique where you have a CDC like Debezium who is log tailing the Outbox table. So a bit code in my application that you can check on GitHub. I will give you the link at the end of the presentation. For example, you have on the top one transaction, which is create customer. You have one command. What do? You map your customer command to your customer. You set the UUID. You you save the customer in your repository, and then you create your customer, you persist to the event Outbox table. And what does it do? You can see below. Actually, with Quarkus and Debezium, there's an extension, and it doesn't fire an event, not much as you can see. It actually persisted to the Outbox table, which is after tailed by Debezium CDC, which will put a message in the Kafka message broker queue. So this is just a snippet from my code that you can check online. After that, we have the Saga pattern. So Saga pattern is essential when you have distributed transaction over different microservices. You have sequence of transaction where each transaction update data is in the single services, and sometimes when you have many microservices, you cannot have a trace of each of them. So you need a way, you need a pattern to be able to debug in case of problems, to be able to just make sense about everything and not in these transactions. Sorry, I need to go faster. When something is failing inside this Saga pattern, you have what we call compensation actions in Saga, which essentially roll back your whole operation from your order. If the payment failed or the restaurant didn't approve, then it will roll back from the beginning of the transaction. There's two types of Saga: orchestrated and coordination. Orchestration and coordination. You can ask me after in the Q&A if you want more detail. I won't go into detail. I personally use orchestrated in my project. It ensures consistency. It's isolating the failures, and Saga once again fits naturally into event-driven architecture because events can be triggered to local transaction outbox and in different service and communicate failure success, where you can do compensation or validate your order. So this is basically what I implemented in my project. You have your order. First, you have your order created. It goes inside the Outbox table. You go through the Kafka topic. It goes to the payments. The payments is completed. It didn't fail. Then the order, the orchestrator of the Saga, is sending to the restaurant order page. You can now prepare the order. The order is approved, and then it's sent back to the order, where the customer can track your actual transaction. Then you have not the happy path, the failing path, where the order is created, the order is paid, but turns out the restaurant is out of stock, so they cannot accept the order. So the order is rejected. I know it's a dumb case, but still, it's just for the purpose of demonstration. the order rejects. Now the order microservice have to do the compensation unit and rollback, and the payment has to do the rollback itself too, because the order was rejected. So if the customer was has to be refunded or something like this, it has to be consistent everywhere. Last pattern, and I want to finish by the most complicated one, even though I didn't talk about event sourcing, and I'm not gonna. The common query responsibility segregation pattern, which is called Securus. So Securus is about separating the command from the query, as you could have seen in my hierarchy of folders. So it separates what you write using your ORM or anything inside your database from the read actions. It's a different kind of storage. Or it can be the same storage, but it optimized for reads and it optimized for write. Basically, the commands, the write, are not coupled to the read. It's event driven. Uh, it allows microservice flexibility. It enhances performance because you can read, write. There are caveats to this, and we can talk about it after. And I can see it coming. And it fits very well with hexagonal architecture and DDD. Basically, you can with Securus, you can have like your RM doing all the right, like using Hibernate or Entity Framework for .NET, and for the read, you can have, if you don't want to add another storage, you can have some kind of views and some optimized badass SQL queries reading your model for reading. Or you can have some kind of Elasticsearch if you want to have performance on the read side, but you have to keep both type. Sorry, you have to keep both them consistent. Meaning, when there's a write, an event using Outbox table or any kind of other pattern have to go to the other storage if you're using a different storage or if you're using a different kind of view in your storage for the user to be able to read. Because the user, when you're using Securus, has to accept the fact that when he saves something in his database, he's not going to be able to read it in the nanosecond after. You cannot say something is created, it's just the event which was sent, and eventually, which is called eventual consistency in Securus, is going to be consistent across all your system, but it's not going to be at the T time. And you don't, if you're doing a pure CRUD and you want your stuff immediately after you persisted it, Securus is not for you. You have to accept that Securus is eventually consistent. So it's not going to be immediately the same thing in your write model and in your read model. So yeah, basically I took this from the Martin Fowler blog, which is exactly what I said. The first on the top is when you have your read and write model on the same, and the model reads from the database, service provided information, user makes change forwarded, model data database. That's it. And in the second one, you have two models, the query model and the command model. So this is basically what exactly I explained, but I wanted to put some Martin Fuller bits in there because he's an awesome person. And that's it for me. But no, wait, just go there and you can see my fully fledged project implemented here. And now it's over for me. And I hope I'm still in. I think I overdid it. But, anyways, I'm good to go now. Okay, for the Q&A.
Great, great. Thank you very much. Very
I know
concise.
that's a lot of content, but
No, but very no. In all the slides, everything was very clear. So let's go to the Q&A session, and it's going to be only with you. So and we have many
okay, no
questions
problem.
already. Okay, so let me add this first one. By the terminology domain event, do you mean something that happens within one bounded context or other several ones present in the whole domain?
So basically, there's different school of thoughts. Uh, if you're purely DDD thinking, domain events is something that trigger another domain inside your bounded context operation. It's just a business rule, let's say. Uh, but the way I see it, and that's the way I extend DDD to be able to be event driven, is that I extract those domain events uh, to make them usable inside my event domain architecture. So the domain events triggered inside the bounded context are going to be triggered outside of microservice to be exploited by other microservices and other bounded contexts.
Okay, let's go to the next one. How will you materialize strategic design to artifacts and make them testable? Strategic design.
Okay, let's decipher the question first. How you material strategic design to artifacts and make them testable? Um, okay, I'm not sure what is the hint on this question, but what can I say that uh, at the point of strategic design in domain-driven design, you're not talking about testability in the sense of software, but which is a good case is behavior-driven design, where this come in case, because in strategic design you identify your domain events, and this BDD, which is not a testing framework, which is a methodology, can be used after to do some TDD and testing using those domain events and scenarios that you have completed with the stakeholders to make them possible to be testable. But I'm not sure what the question is really about, so it's hard for me to answer right now. But yeah, I guess testability is not really there at the time of strategic design in DDD.
No, I think that answers the question. No, because probably the doubt is if how this can be something testable, but
I get
you already answered.
the testability is done after the testability is done during the implementation, and even at the tactical design, because you already have your entities, you have your business rules, you have your domain service. This is tangible thing. You can actually test this. You can have you have unit tests in sense of unit, instead of scenario based tests,
Mhm.
which test, but not at the strategic level, at the tactical level.
Okay. Okay. Next question: do you have any experience playing architectural katas for event storming? Can you suggest any practice in this approach?
Yes, a kata would be. Um, I think. Well, I have some videos and materials I can share with the person who asked this question. But yeah, you can. I don't have any exact scenario where you can do this, but basically just take the maybe the one full-fledged spec from some kind of I don't know. You have access to some kind of specifications, and you have access to people who have knowledge about this. And because uh, to do a kata about even storming, everybody needs to know the business. So you cannot do something out of nothing. So you can do a kata if everybody reads the documentation and the specification of a domain of a business beforehand doing the kata. So you need people who have knowledge in order to do even storming. Otherwise, it's pointless. Nobody is going to put sticky notes on something they don't know. That's why you involve everybody. Usually, the product owners, the customers, the people who owns the business will have many sticky notes. The developers will just watch and discuss. But to do a kata, you need like I don't know, just take a big specification. Everybody reads it, and everybody put some sticky notes on the whiteboard
what they understood. So yeah, here there was like some event I could understand, the user registered, the user logged in, or something like this. But there's no kata that I know of who you can experience this. But my advice would be that you actually read some kind of specification and gather with your team who you didn't talk to before, and then do some sticky note stuff.
Good point. Thank you. So now we have two part question here. So let's go with the first part. Over time, I started to believe that using messaging to propagate domain events to other bounded contexts adds undesired technological coupling between them. And the second
I
part,
think I need the second part.
yeah, no, I prefer to handle listen domain events with messaging locally in my bounded context, and then propagate actions to other bounded contexts using API call. Do you have an opinion about that? I have a lot.
Yeah. Basically, what you're saying is that you think that if you basically what you're going against, and this is actually why I said don't do microservices because it's cool, don't do event driven architecture because it's cool, don't split your simple modular monolith into many microservices just because it's cool to have microservices. If a modular small simple monolith distributed works, it works. You don't need events to make it work. You need events when you want this decoupling. It's, for me, if you introduce this notion of event driven, and this is because of a need, because it's because of a bottleneck, you have something in your monolith. You introduce this so other microservice can do the task whilst you still work on something. So basically, you just, if you need, first of all, if you need to do REST API between microservice, why split them between microservices? Just put them in the same monolith, please. That's because the base of the event driven domain architecture is to be asynchronous. You don't make REST API call to other microservice. You talk only via message brokers and messages. Otherwise, it's the same as doing a freaking modular monolith. Don't do microservice and event-driven architecture if you don't need it. If you're tightly coupled, don't decouple it. Just keep it simple. Keep it simple, stupid. My example is stupid because it can be a modular monolith with no need absolutely for event-driven architecture. It's tightly coupled. It would be a cool modular monolith. It's just for the sake of example. But Hugo, please give me your opinion about it.
Well, I totally agree with you to start with, and given that in a few we're going to switch chairs, and I'm going to do a talk. I'm going to address this topic too. So I think
Okay, I will watch the
we'll
video.
reserve for that. Okay.
Okay.
Okay. So let's go with the next question here. What is Kafka in short? Just a message broker, or does it have any
In,
special?
in short, in short, I like the in short question. There's no in short in Kafka. It started with a pub sub. I don't want to piss people off at LinkedIn who invented it. A simple distributed pub sub system. Now it's pretty much doing everything you want. It can be an event store. It can be a message queue, because originally it's not supposed to be a message queue like RabbitMQ and MNQP. It's supposed to be a pub sub service. That's what it does the best. But now it's also a distributed cache, so there's no in short in Kafka. But my guess on this is use it for what it does best, which is pub sub, and keep it to it. Don't try to do everything with Kafka. Don't try to do even even sourcing with Kafka if you don't need to. Don't try to put everything in the Kafka message queue, and then that just doesn't work. And the schema registry thing is becoming hell. And so there's no Kafka in short, but just for me, use it as a pop sub with the small feature they have that does great, and then I think that's enough. But it does
Okay.
a lot of things.
Yeah, yeah, yeah. He's a good broker, and yeah, certainly you can also see others, that are that have similar
Yeah,
features,
I I,
and
I like Pulsar too. I like Pulsar, which
yeah, I think we
kind
need to
of.
work together because I like it. All right. I think, well, there are a lot of questions, by the way, yeah, but
Yeah, I can
because
see them.
I
Because I'm moderating after you. I can
exactly
see
no,
the
no, no.
question.
Yeah.
I will
So
answer them in the chat if I have time. Okay.
yeah, yeah. Do it, please. And now I think it's time for a quick break. So thank you very much,
Yeah.
no, for the time, and
Thank
see
you,
you
Hugo.
in a few.
And yeah, yeah, I will be asking questions. See you later.
Okay. Okay.
Bye.
Thank you.